Good morning, everyone, and welcome to our WEkEO webinar today on the 30th of July. And welcome to our sixth webinar already of WEkEO DS. Today, we'll be introducing the platform to you, as in the previous sessions, and give you a first insight into the tools available, as well as the new products in the WEkEO catalog. My name is Joanna, and I'll be your moderator for today as well. We'll be also taking questions towards the end of the session as usual. And we have lined up some experts that I will be presenting to you right now. Our speakers today will guide you on the discovery and the journey to dive into the new catalog and the new products of the WEkEO DS. So without further ado, these are our excellent speakers and experts that will be guiding you this morning. And we have Mr. Stefan Orevich, who's been involved in the WEkEO user support as a senior advisor. He has been involved in Copernicus user uptake activities for more than 15 years right now, and is an expert in Copernicus market development and user engagement. In addition, we have Mr. Fabrice Messal, who is the training and educational manager at Mercator Ocean International. After the 6 years developing partnerships and projects in the frame of Mercator Ocean outreach activities, he's currently in charge of the training activities for the Copernicus Marine Environment Monitoring Service, the CMEMS, so-called. Fabrice has a background in science and applications, numerical imagery, and has a professional experience as well in visualization, software development, and scientific mediation. In addition, we got Mr. Ludwig Forslund, from Copernicus Land Monitoring Expert at the European Environment Agency based in Copenhagen. Lovely to have you with us this morning. And Mr. Forslund is leading the Vegetation Phenology and Productivity Time Series dataset production and user outreach for the Copernicus Land Monitoring Service. So CLMS. We're very glad to have also Mrs. Gabriela Schweitzer from Austria on our panel this morning. She's a senior research scientist at NVOIT and has been working for more than 15 years on the monitoring of seasonal snow and land ice using satellite data, and is leading the operation of snow services at NVO. Good morning, very warm welcome. And finally, as usual in our series, we have our expert, Mr. Amin El Amrani, who is the satellite imagery expert. And he is a WEkEO user support expert as well, specialized in technical issues. He deals daily with our user support issues as well. As per usual, we will be taking your questions. I will mention that again towards the end of the session, but you can already start putting any questions in the question and answer Q&A section throughout the seminar. And all our experts will give you a broad overview into the new catalog this morning, and hope we will enjoy the seminar. And here is just a brief outlook of into the agenda, today's agenda. We're going to kick off with Mr. Stefan Orevich and WEkEO user support overview. Then we have the ever-changing WEkEO data catalog, the new CLMS data from European Environment Agency with Mr. Ludwig Forslund. Then we're going to have a live demonstration by Mrs. Schweitzer from NVOIT, followed by Mr. Fabrice Messal and Mercator Ocean International, looking into the evolution of the CMEMS data catalog included in the WEkEO. We will dive into the questions then and reply to all your questions. And today we're not going to be taking a break exceptionally, so we're hoping to end a bit earlier. And without further ado, we can skip the rules because I've already mentioned about the questions. I can give the floor to Stefan.
Thank you, Joanna. Let me share my screen here.
Thank you.
Hoping it works. Yeah, I guess it does. So yes, very warm welcome to all of you to the last of our 2022 series of training webinars. I'll once again, for those who did not participate in previous editions, give you a quick rundown on the main features of WEkEO and why we believe it should be your number one choice for accessing the Copernicus data and information, both from the Sentinel satellites and from the thematic services of Copernicus. Today, we decided to also give you a presentation focused on not the new portfolio, but the new products in the portfolio, or the new version of the portfolio, if you wish. Copernicus products are constantly evolving. They're evolving, because user requirements are evolving, and since day one, Copernicus has always done its utmost the best to be a user-driven service. So collecting new requirements, we develop new products, or we improve existing products, and also the evolution of new products being deployed, new data sets of the Sentinel satellites being released, improvement of existing products. All of that makes WEkEO an ever-evolving platform in which there are regular new releases, and we thought it was worthwhile to conclude this series of webinars by introducing those new products to you. So, what is WEkEO? WEkEO is one of the data and information access services of Copernicus. The idea is to, instead of having to download very heavy data and process it on your computers and store it, etc., is to allow you to visualize, download the data from a cloud-based, let's say a subset, and also to process and store the data in the cloud. To build WEkEO, 4 of the main actors of the Copernicus ecosystem, by main actors, I mean entities, institutions that have been entrusted with the production and delivery of major chunks of the Copernicus catalogue. You see the list on the right: EUMETSAT, ECMWF, the European Environment Agency, and Mercator Ocean International. These are the institutions that provide the marine data for Sentinel-3, that provide the climate change and the atmosphere service, that provide the Copernicus land monitoring service, and which provide the Copernicus marine environment monitoring service. So you've really got like the vast majority over there. Public institutions, not private companies, and a DIAS whose future is ensured. Late last year, the European Commission renewed for 7 years the mandate of these institutions to make the WEkEO DIAS available to its users. So it's a long-term commitment, which obviously allows user to bet on WEkEO to build long-term applications, industrial applications, time-critical applications, etc. What makes WEkEO, one of the features that makes WEkEO unique, apart from the fact that it was built and it's operated by the custodians and the implementers of most of the Copernicus data, it's its distributed architecture. By distributed architecture, we mean that we don't duplicate the data. We just organize the system so the data can be fetched where it's currently hosted, as part of the service delivery of each one of the partners. That gives you, firstly, the assurance that you always have access to the latest version of the data because we pick it from where it's, let's say, the freshest. Another element is, as there is no duplication, we believe we are the most climate-friendly DIAS, as we don't have to use expensive and energy-consuming resources to store data that is duplicated and is already resident somewhere else. And finally, it ensures a very strong scalability in the sense that the custodians of the data, whenever there's another the new data set, a new product, it's nearly automatically and seamlessly deployed into the WEkEO platform. And that's in fact the raison d'etre of this webinar, to show you that it's constantly evolving and there are new things which you may want to use. So WEkEO is both the Copernicus data from the Sentinel satellites, data from the services. It's a virtual environment where you have tools for processing the data, virtual machines, GPUs, storage facilities, tools, and yet another unique feature of WEkEO, a very strong user support, because who knows the data, the information, the products better than those who develop it? Nobody, obviously. So by using WEkEO, you can rely on a user support where your questions will be answered by experts that sit at the user support or that sit within the partner organizations which are behind WEkEO and who are available to answer any kind of question, whether it's on the IT side of the platform or whether it's on the characteristics and specifications and potential use cases of the data and information. So I think this we can skip because I've already mentioned all those elements, but the point is that thanks to a harmonized data structure, thanks to a harmonized data access, it makes the process very much seamless. You don't have to go to 4 different platforms to get the data. You get into one and you get the freshest and you get the one that, let's say, has the most ensured sustainability. WEkEO is tailored to cater for the needs of all types of users, from very specialized people, researchers, academia, to the public sector, institutional bodies, civil society, but also a stream of startups and entrepreneurs who are building new services based on Copernicus open data. The catalog, well, the catalog is easily accessible. You can visualize and download most of the data. You can visualize the data without registering. You can download it after registering, and you can process it and store it after subscribing for one of the plans that I will describe further. So you have the partners I described, all the data from Sentinel 1, Sentinel 2, Sentinel 3, so radar data, optical data, medium resolution data, and we will soon introduce the Sentinel 6 microfreilicht data, so radar altimetry, measurements of the level of the ocean, so a critical tool to monitor sea level rise, as well as the products of the Copernicus, the various Copernicus services. Another thing is the existence of a marketplace where users free of charge can advertise their applications using WEkEO and Copernicus data. The data sets available in WEkEO currently are 310, but it's changing very regularly. But it's quite a high number, and I believe it's the highest number of data sets available on any of the existing DSs. We also feature in the platform a easy to use, rather beautiful because it also gives very nice visualization, a viewer that enables to view the data, and that viewer doesn't require a PhD or extensive remote sensing experience to be used. The user support is organized in 2 levels. Level 1 support answers easy questions, I would say, or questions for which the answer is in our wiki, in our database of frequently asked questions, while level 2 support is operated by senior experts from all the participating organizations and from specialized contractors. You also have quite a lot of support material, dedicated documentation, FAQ, a YouTube channel in which all our webinars and training sessions are published after being recorded. You also can use social media to contact WEkEO, etc. Again, quite a wealth of information is available online, which makes your user experience rather enriching in the sense that you don't have to look around too much. A lot of the information is concentrated in one place and can be easily browsed by users. Our YouTube channel, as I said, includes all the webinars and training sessions, and this session will be placed early next week, I guess, on the channel so that it can also be seen by people that are new to WEkEO. We organize training sessions and webinars. Some of them are generic, some of them are thematic, but there's now quite a vast collection. I'll come to it in my concluding remarks, but I think there are now this is the second series of webinars, and we have, I think, a total of 22 webinars that have been performed and recorded and are available online. You can also follow us on social media, where we try to be interesting, really not making publicity or advertising, but more informing about any news regarding the platform. And we also take on questions on social media as if they were asked through the user support by email. User support you can access either by filling the online form or by using the support@wekeo.eu functional mailbox, behind which you have quite a number of level 1 support agents that are there to cater for your queries. The pricing. Most, as I said, of the things you want to do are free of charge. The only one that you need to pay for is the computing, is access computing powers, GPUs, and storage. But let's say because WEkEO is not run by any commercial organization, the idea is to cover the costs, not to make a profit, which also makes a difference as the other DSs are operated by private companies, co-funded by the European Commission, at least until now. And therefore, they have a different view of the purpose of the platform. So again, everything's free but the processing and storage. The plans are going from the essential to very advanced plans. You see it starts rather cheap at 125 euros per month, and it can go to thousands of euros per month for organizations or companies that are developing an operational product. And we have such cases of companies who are delivering a service or are producing a data set for Copernicus or for other purposes that use RDS, knowing that there's quite generous grace trial periods, 5 months for the delight, and that we're usually open to extending those trial periods for projects that either have a high societal impact or demonstrate new uses of Copernicus data or are carried forward by organizations that do not have necessarily large budgets, such as universities or research centers. We have a very complete Jupyter lab in which you can find many Jupyter notebooks together with a GitHub support and many useful modules where you can basically get very good examples of many different uses of Copernicus data for land applications, for marine applications, for atmospheric applications, for climate change monitoring, etc. So join our community, visit our web portal, follow us on social media, and don't hesitate to use the expert services of our user support team. This being said, we can move directly now to the many additions that the Copernicus Land Monitoring Service has included in the WEkEO catalog over the past few months. So I guess, Ludwig, the floor, the virtual floor is yours after I stop sharing my screen.
Thank you very much, Stefan. Let me see here if I can start sharing mine. All right, it should be visible now. Okay, thank you very much, Stefan. Again, my name is Ludwig Forslund, and I'm a Copernicus land monitoring expert working in the Copernicus Land Monitoring Service at the European Environment Agency in Copenhagen. As mentioned earlier, I'm leading the high-resolution vegetation phenology and productivity production, which I will get into a bit later. And I'm also working in the user outreach and input data to the CLMS, representing the team in mostly in Sentinel-2, ESA working groups, etc. There we go. So just a bit of overview of my today talk. I will first start off with describing and presenting a bit on the high resolution vegetation phenology and productivity. I will also mention briefly on snow and ice, since this has been mentioned in previous webinars, but today my colleague Gabriel will also take over the other half of this session and showcase a hands-on Jupyter example using snow and ice. So I will just briefly go through the products there. And then I will also introduce the European Ground Motion Service, which is a newly released service under the CLMS umbrella. So starting off with the high resolution vegetation phenology and productivity, which is quite a tongue twister. So usually it goes under HRVPP, the abbreviation that is. So firstly, to get into this product, I usually like to start with the definition of these two words. So the phenology is the timing of development of photosynthetically active leaf foliage, which in other words can be described as the vegetation seasonality and activity. And the other part is productivity, which is a bit easier, the accumulation of vegetation biomass. So estimated from the measured activity. So they go hand in hand. By monitoring the vegetation activity, we can, throughout the year and years, we can then estimate the productivity and biomass accumulated. In the top right, I have a simple illustration of this phenomenon, the phenology, where we move from spring to summer to autumn to winter. We see here during the year the activity represented as a curve. This is what we usually look at when we talk about phenology. In the bottom left here, no, bottom right, I have a small GIF just visualizing the data set throughout the year. It's an above view rolling through the dates of photosynthetic activity over some agricultural fields in France. And as you see here, the colors represent, so in winter, we move into winter now. It's getting blue, so low activity. And when we move into summer of 2019 here, we get more and more fields waking up, and the activity increases into the reds. So what I want to visualize here is, of course, both the seasonality of winter and summer, but also the spatial distribution of the different fields and their respective activity due to the crop cover and so on. So of course, there's a lot of interesting use cases for a product such as this. We have the carbon sequestration, when, in other words, measuring carbon uptake and storage in vegetation. We can study climate impact in detail from fire, drought, and frost events. Of course, we can use this data for crop type monitoring or mapping and crop type rotation monitoring, which is upcoming products in CLMS, and we're starting production of these right now. And we can also monitor agricultural practices. We can see where we have cover crops, fallow lands, etc. The urban ecosystems are also an interesting application, looking at urban vegetation, for example, and the monitoring of grass mowing events, where we can highlight where we have cutting and grazing during the vegetation season, either from machines or from livestock. And of course, the policy context is quite vast as well. These feed into the Green Deal, many of these use cases, and biodiversity studies, soil, or how vegetation affects soil, the common agricultural policy, and in the case of carbon sequestration, the LULUCF use case. Just quickly, I want to visualize the three major sections of the HRVPP products. So first, we produce the vegetation indices, and here you see it rolling according to the Sentinel-2 acquisitions over Europe, or over what we call the EA38 plus UK. It's our area of interest for our production. So these are the daily acquisitions of Sentinel-2, derived here into plant phenology index, which is our main index for this production, but we also produce and disseminate 3 other indices as well. Further, this feeds into the seasonal trajectories, which are derived from time series function fitting for the vegetation index, plant phenology index. And they are produced on a 10-day time step. And here showing an image of some agricultural fields again, of how it looks like as a snapshot. Then we come to the parameters for phenology and production. So first we have 7 phenology related parameters. These are produced yearly for 2 growing seasons. Usually in Europe, or in the southern part at least, we have 2 growing seasons, a major one and a minor one. And these consist of the start and end and length of the growing season. We also derive the season minimum maximum activity, and from this, so imagine the curve in the last slide, from knowing the minimum and maximum activity during the year, we can also derive the amplitude. We also derive the slope of the graph, so the green up during spring and the senescence during autumn, to get kind of the characteristic of that growing seasons up and down. Further into the productivity parameters, we also derive the seasonal productivity and the total productivity. And in the image above, you see the start of season for, I think it's 2020 or 2019, where you clearly see from blue in Southern Europe, which represent the start of season in around February, to the yellow, to the red and yellow in the northern parts, which represent the start of season around May. Okay, so further, I will briefly describe a bit on our snow and ice monitoring product, also derived from Sentinel-2, but also uses Sentinel-1 SAR data. So the snow and ice product describes the snow properties on land and ice occurrences in the hydrographic network. This type of observation is part of a larger whole in the cryosphere observations. And as you see, the GIF here on the top right shows an illustration of the melting in the Alps throughout April to July in 2018. And you can notice how the dry snow in blue color and transforms to wet snow in purple color, and eventually then melts out, as you see when it moves into July. Most of the snow and ice data is disseminated in near real time. This means that it's made available within 6 to 12 hours of satellite observation. And the data set is generated just like the HRVPP over the entire EA38 plus UK. Again, snow and ice monitoring are critical parameters. This for a wide range of application in the field of weather and climate, for example, hydrology and water management. We also have this snow and ice covers are essential for assessing natural hazards. So floods, avalanches, river ice jams, for example. And they provide background information for the development of policies related to water supply, climate change adaptations, and disaster risk reduction. And again, here is the time series from 16 to 22 and updated daily. Just on the different products in the snow and ice portfolio, we have 5 snow products. So here I start with the 2 for snow cover, where we have this fractional snow cover providing the snow fraction per pixel on the top of canopy and on the ground. And then we also produce a daily cumulative gap-filled fractional snow cover, which kind of completes the fractional snow cover. Further, we have 2 for snow state conditions. So we map the wet and dry snow products, as you saw in the GIF in the previous slide. So this differentiates the snow state condition. And we have the SAR-derived wet snow product that provides information on the wet snow extent in high mountain areas. Additionally, we produce a persistent snow area product. This is produced on a yearly basis and provides the extent of persistent snow cover, meaning the area where snow is persistent throughout the year. And then to the ice products, we have so these are defined in the hydrographic network, as I described earlier. We have the river and lake ice extent product, providing information on the ice cover of these. And further, the aggregated river and lake ice extent. Here you see it's doubled here with red from our other product, the EU Hydro, which is a hydrographic network dataset. Okay, as I mentioned, I also want to showcase a bit on our newest product, the European Ground Monitoring Service. It was released in May of this year, and the full service will be available mid-July 2022, but you can already go and look at the product in the viewer. It's based, so this is based purely on Sentinel-1 SAR data and monitoring the ground motion, so in elevation change throughout the time series. And it's a homogeneous continental scale of ground motion. And it provides information on ground and infrastructure displacement, including landslide, subsidence, and tectonics. And here's a small extract of the application where you can click on each of these points you see in the image and get the time series profile for that point. For this point in particular, you have around a 1 decimeter land subsidence for the time series of 5 years. There's also further interesting use cases here. So, for example, analyzing effects of mining on the surrounding landscape, and additionally, studying the subsidence of buildings, road, bridges, power plants, where you have dug down pipelines. You see how they affect its surrounding landscape in subsidence, etc. So a very interesting data set to click around in. I can highly recommend. You will get lost in there for a while. It's not on WEkEO yet, but the migration is planned within a year. So we're really looking forward to getting this product to the WEkEO platform as well. So just quickly on a bit of a data access. Of course, so the two first products I described here are on the WEkEO platform, or solely on the WEkEO platform. I also recommend I include some links here to our land portal where you get kind of in-depth information if you start using the products. So you can go into, this is for the HRVPP, you can go into the different sections and really get to learn about the product. And as you see, the data access takes you eventually some additional information to the WEkEO platform, where I think you are knowledgeable on how to find the product. So for example, clicking the plus sign here and searching for phenology, you find this data set, right? And snow and ice, you find that data set and all the different products I've described today. And for both of these are time series products. So of course, the time slider down below is of importance for moving throughout the years. And then we just now started publishing Jupyter notebooks in the WEkEO for Land repository, and which are also, of course, available in the WEkEO Jupyter Hub. And we recently published 2 scripts for related to snow and ice, which are coming up, a hands-on example from Gabriele, and more scripts are to come. So both in HRVPP, coastal zones is another data set that I haven't mentioned today, but we will publish more and more hands-on scripts for these products. And there's also a small tutorial on accessing our products. I recommend you checking that out through the WEkEO HDA. So you can get started on accessing the CLMS portfolio on WEkEO. Thank you very much. Now I want to leave the floor to Gabrielle. Or maybe Stefan wants to say something in between.
No. We may just answer a question that popped up on the Q&A while you were speaking.
Yep.
It's a simple one. The question is, what is the fractional snow cover dataset coverage so far? Is it globally available? Then unfortunately, we have to answer that the products of the pan-European component and local components, by definition, with their name of the Copernicus Land Monitoring Service, are not restricted, but are only published for, in most cases, the countries member and associated to the European Environment Agency. So it includes it includes in most cases Turkeys and countries in the Balkan. For EGMS, it's restricted to for the ground movement, it's restricted to the Copernicus participating countries plus the UK, because when the production was launched, they were still a member of the European Union. But I want to point out that in the Copernicus Land Monitoring Service global component, you do have products on the cryosphere that provide global coverage, but not obviously with the same depth and not with the same high resolution, and not with the same, especially for snow, the same near real-time availability of the data.
Exactly. Yeah. So as I visualized here a bit on the snow and ice product, we have our usual area of interest, as we call it, for the EA38 plus UK. This is where we usually produce our products, or this is the extent we produce our products for in the CLMS pan-European component. So yeah. Okay.
So we can move to Gabriele.
Yeah, thank you very much. Is there another? I stopped sharing at least, but maybe there was another question as well.
Is PPI a specific index?
Yes, it is a specific index. It's similar to the NDVI, but it's specialized on the application of phenology. You get a bit more information in the green up and senescence and so on. So that is why it's chosen for this product. We collaborate with Lund University on this product and used a software that they produced called TimeSat, and that is based on plant phenology index. But as I described as well, we also publish indices for NDVI and FA PAR, etc. So they can be used as the basis for further analysis.
Thank you, Ludwig. Gabrielle, up to you.
Thank you very much for the introduction. And my name is Gabriele Schweitzer. I'm working at WEkEO in Innsbruck in Austria. And I will show you now a kind of demonstration for how to use the WEkEO product from SAR data to get some further information out of that. And I will do this with the help of a Jupyter notebook, which is actually a bit slightly adapted from the template, which is now available on the WEkEO for Land, what Ludwig introduced before already. It's the analysis of the wet snow extent from SAR wet snow time series independence of the altitude and of the local aspects of the slope orientation. I'm using now a data set what I have downloaded from the WEkEO hub just to my local storage. And what I need additionally here for this analysis is a digital elevation model in the same map projection and in the same grid spacing as the products are. So that means for the SAR wet snow product, we have the products available in a UTM map projection with 60 meters times 60 meter grid spacing per pixel. And that means for me, I use the Copernicus digital elevation model as auxiliary layer for getting the altitude and to calculate the local aspect from. And I have to prepare this in a first step in advance to the same geometry as the SAR wet snow products. This is not included in this Jupyter notebook, but that has been done as a step before, as a kind of pre-processing step. And I will not go into detail about that. But if you have any questions about this, you can always contact me. The Jupyter notebook is actually based on only standard modules and packages from Python. And I think I linked everything which is needed here in this description. We are just importing now all these packages and making sure that everything is working well. One important thing, what is needed for this Jupyter notebook is a cheetah library, because that is what is needed to read all the geotiffs downloaded from the WEkEO catalog. Then we have defined a function to open and read actually the geotiff files. So both the SAR wet snow products, but also the digital elevation model, what we are needing. So we just go through this. It's just opening, getting all the required information, reading the data as an array, and returns finally the data what we are aimed to analyze finally. Next step is that we need a function to calculate the local aspect from the digital elevation model. It's very simple, so I think we don't need to go through that in very much detail. And then the only thing to be adapted by a user is actually the passes where to find the products. And I've entered here now the path where I have stored the products on my local disk. What we want to read is actually all the SAR wet snow products, which are downloaded as zip geotiff files. So first you have to unzip all of them. And then you should have a list of SAR wet snow products, which are ending with a WSM for the wet snow products in mountains. And additionally, as mentioned before, I've prepared this digital elevation model that is used now only for one granule, for 132 granule, this of the tone of the UTM zone 32, and with the ID TMS. And that is prepared in the 60-meter grid spacing to match the geometry of the Sarah-Wetzner products. So I want to get now a list of all these data sets which are in my local storage, and you see now that I get the complete list of the downloaded data set. I selected now 4 different timestamps of the Sarah-Wetzner products of the year 2018, starting in mid of April. Then we have one in mid of May. Then we have another one in early June and another one in early July. So we have now more or less 4 months covered, and we want to analyze how the wet snow extent is developing within this time frame. Now we are just calling the retif, this function what we have defined before to get all the information for the digital elevation model. We saw this in this variable elevate data. Based on this elevation data, what we just read, we are calculating now the aspect, the local aspect. And actually, I'd like to see how this is looking like. So this is not just a simple plot showing this aspect information in degrees, scaled between 0 and 360, of course. So 0 and 360 is the same, that's facing north, and 180 is facing south. And it looks quite good here. So let's continue. The next step is now to get an idea, how is the area of interest, how does it actually look like in terms of elevation and in terms of general aspects. And as we are looking here at the wet snow conditions, and in particular in a very, very high mountain domain, we are checking only for values with altitudes more above 1,000 meters above sea level. So we are selecting here all the elevation data over 1,000 meters and getting then the elevation data and the aspect data for this selection. And we are combining all these different data sets into a pandas data frame. And then we use the windrows that's available via the GitHub. It's just a method to illustrate things like different things in a windrows graphic. And actually, if it just run it, it takes a little bit. Let's see if it does something. Ah, yeah, now it comes. And now we see that we have here the distribution of the aspect in dependence of elevations, and we used here elevation intervals of above of 500 meters, so starting from 1,000 meters up to more than 4,000 meters. So I think the highest elevation in this tile is something around 4,300 meters or so. So we are really in the main alpine region here. And then you can see for each of these orientations the amount of the DM and how these elevations are distributed. And you see this, each color is now representing one of these elevation bins. And of course, the highest elevations are have the smallest amount here. So it's given here in percentage what is really included in these regions. So this is actually now the very basis what we are using for the analysis. Now let's come to the product what we want to analyze. So we are getting now all the different files what we have listed before into another pandas node data frame. We are reading it again with this function we have seen before for reading geotiff files. Additionally, I'm interested in the product date for each of those products to be added, and I'd like to get a proper color coding for all these different products as it is also shown in the catalog at WEkEO. So these are not just the color codes in hex format to assure that we have the same illustration as it is seen on the WEkEO catalog. We are reading then everything, converting everything, and finally we are generating here the figures, including some nice legends and titles and so on. So let's run this. And what comes out now is actually basically the same information what you can see on the WEkEO catalog for the Sarah-Wetzner product. and for these selected dates, what we have read into our data frame. So this is how it looks like in mid of April. You see in purple all the melting snow areas. In this cyan color, that is still dry snow. So that is at the highest elevation when the snow did not yet start to melt, but that is called dry snow. And then we have some forested areas, and so, but we are not going into detail for these classes. So we are actually only interested now in the melting snow extent. If we go now to about a month later in May, mid of May, you see that in the lower parts, the snow is already gone in that case, and the melting snow extent has moved up to the higher elevations. So that's pretty much well visible here. Another month later, we have even more snow melted at the lower elevations, but the melting snow extent is more or less remaining for all the snow-covered areas which are remaining in early June 2018. And if you go to early July 2018, you see that most of the snow areas which are now remaining are actually on glaciated areas. So in that, I'm not sure if you see my mouse, but in the central left part of this image, you see the Aletsch Glacier, for instance. So it's the biggest glacier in the Swiss Alps. And all these wet snow areas are really remaining at other high altitudes in the mountain terrain. Now we want to get for all of these samples the actual aspect and elevation information. That means we want to get some further analysis for these products. And therefore we extract now only the wet snow information that is coded with the value 110 in these products. And we are getting now again a data frame for the wet snow extent, extracting the elevation for all these wet snow pixels and the local aspect information for all the wet snow pixels. We are bringing everything again together in a data frame, appending everything, and then we are generating again windroses. We are using now a different method to display the windroses or the information using contour lines instead of bars, but we are keeping the same elevation intervals what we have used before. So from 1,000 meters up to 4,500 meters with 500 meters elevation intervals. And we keep also the same percentages as we have seen before for the overall local aspect distribution. So if we run this, then we end up here in windrows figures for each of those dates. So this is now starting in mid of April, and you see that we have here the melting snow extent rather at lower elevations. And this is exactly in line what we have seen at the maps before. So the upper elevations, so everything which would be here red, orange, or yellow, that is still dry snow. So it's not yet included here. But if you go then to May, it looks a little bit different. So now you see that the melting started already at higher elevations up to above than 3,000 meters. But the snow at the lowest elevations is already almost gone. So we see here really the evolution of the melting snow extent. If we then go to June, early June, it started even melting above 4,000 meters. So that is here the bright yellow line. It's still close together with this interval between 3,500 and 4,000 meters, but all the snow below 2,000 meters has already been melted. So here we are. It's a very tiny point is in the middle of the windrows, but it's almost all gone. And then if we go to July, you see that we really have now the snow remaining only at the highest elevations, and that is exactly what we have seen before. So we have the snow remaining mainly on the glaciated areas, which are starting well above 2,000 meters, which is a small circle in the middle. And then we have the main melting areas above 3,500 meters and going up to more than 5,000 meters. Of course, you're welcome to adapt the notebooks the Jupyter notebooks to your own needs. So this is just one example now to illustrate what could be done with the analysis of the Sarah Wet Snow product, but of course it's adjustable also for other products and for other purposes. So that's up to you then, whatever you're interested in. With that, thank you very much.
Thank you, Gabriella. Thank you very much for this lovely presentation. And yes, we could see your mouse, so it
Perfect.
was really helpful.
Thank you.
And we can give the floor to our next speaker.
Our next speaker being Fabrice.
Yes.
Here we go.
Yeah. Thank you. So let me share my screen. Okay. So I will give this short presentation about the new marine products which will be available on the Copernicus Marine Service. And as Stefan said before, the system of the WEkEO is very simple. We try to connect all the Copernicus Marine Service portfolio together, and it's not we not duplicate all the catalog, but we just connect the catalogs, the different from the different services. So what I will present is the update of the portfolio of the Copernicus Marine Service, who will be directly available on the WEkEO platform. So this is focused on the Copernicus Marine Service, but don't worry, you will be access to these products directly on the WEkEO platform. So let's dive now in the next release, the future of the Copernicus Marine Service portfolio. So first of all, I would like to explain you what you can find, in fact, the inside point of view of the Copernicus Marine Service, to explain how we are dealing with the users' needs, with the innovation in science to manage the evolution of our service. So this is how we built the Copernicus Marine Service software. We have this on one side, the service evolution driven by the science. Okay, we constantly improve our scientific knowledge about the modeling aspect, the qualification of the different products, etc. And we have also, on the other side, the needs and the constraints from the users. And we try to collect these user needs and to see how to merge the two, the science-driven approach and the user-driven approach to create the next evolution of the service. Okay, this is why we try to communicate on the fact that we are really a user-driven approach, a user-driven service. Okay, and how we collect all these user requirements. Okay, we have questionnaires or survey. We can launch this sort of campaign to our user database. We have also the input from the different producers. We have also the user support, who is directly in contact with the users. They can feel the next need, the future needs of the users. We have also what we call the champion user groups. This is a group of around 20 users, so regular users of the Copernicus Marine Service. We have identified these users and they cover the different sectors of marine applications. And we try to keep the contact with them to share our the plan we have for the next evolution, and they share with us on their activity, their daily base activity, what they will need in the future. So we keep the contact with this champion user group to have the best relevant requirement. We have also the training activity. We organize a lot of workshops each year. We are in direct contact with users, and we have direct discussions between the experts and the different users. And we have the other kind of event and workshops we can organize during the year. All these requirements are feeding our user feedback database, and then we make this analysis to check the feasibility on the technical side and the scientific side. And then when we validate this roadmap, it enters in the cycle of the service evolution. Okay, so we need to create a new product. We need to create the new chain to validate and qualify the product, to create all the documentation associated to this product, etc., etc. So this is a long process, and we try to update. To have a major update of the catalog once a year. And so the next big release of the catalog of the Copernicus Marine Service will come in November. We have a roadmap for from 2022 to 2024 for all the products. Okay, we try to work with the different producers on this roadmap, and to make some big improvement about the resolution, the number of variables available, but also different aspects on, for example, about the modeling system, the assimilation of real data in the different models. For example, we will try to improve homogeneity between the different monitoring and forecasting systems. As you must know, we have on the different European basins, different monitoring and forecasting system for the physical ocean, the biogeochemical ocean, sea ice ocean. So we try to homogenize all these systems. We try to interconnect more and more the different modeling systems, because the region can be interconnected. We try to force the model with new information about, for example, the reverse discharge. We try to add new observations in the different monitoring and forecasting systems. This is very essential to have a realistic model. We will have this new, what we call interim reanalysis, updated monthly. The idea of this interim reanalysis is to be connected to the real-time models. So there is some advantages and inconvenience to have this kind of interim reanalysis, but the goal of this one is to have a long time series in the past connected directly with the real-time data products. And also we will have monthly climatologies and new extended reanalysis. This is for the model data products part. On the observations part, this is a roadmap for this incremental evolution in the 2 next years. So we will integrate the new missions with the new Sentinels satellite products. We will try to ingest and qualify more in situ data in the future. We have some new graded products made from in situ and satellite data. So we will try to increase the resolution of these kind of products and provide new variables, again, improve the quality of the different products. Sorry. So this is the big roadmap for the 2 next years for the modeling products and the observation products. We have also major evolutions planned in different topics on the coastal area, on the Arctic region, on marine biology, on ocean climate, and digital services. And I will dive in the coastal, Arctic, and marine biology evolution. So for the coastal ocean, we will provide new satellite products, and we want to improve coastal zone monitoring. This is a real need from the different European member states, and to do that, we will try to co-design with member states the next generation of coastal products in the Copernicus Marine Service Catalogue. The idea is to create what we will call the stakeholder forum. The idea is to identify in each European member state the institution, the agency who are running coastal models. And the idea is during the next years is to plug these coastal products to the Copernicus Marine Service Catalogue and obviously the WEkEO catalog. So it will be a long process to integrate in the marine portfolio these coastal models produced by each European member states. About the Arctic Ocean, so we will have new satellite products available. We will try to modify, improve the portfolio to have something more comprehensive, and we will have also improvement in the different modeling system of CIS variable and CIS products, and obviously the uptake of the future Sentinel missions. On the biogeochemical ocean, again, new process in the biogeochemical models with the new ecosystem modeling with the different trophic levels, with the plankton, the micronecton, and the fish, the monitoring of habitats for key protected species. So again, in this part of the green ocean, also a lot of improvements in the future in the products. So if I want to summarize in the next release of November, because the slides before were on the midterm period evolution. For November, we will have a lot of improvement, a lot of new products or evolution of products. This is just an example of some of these products. What we have to keep in mind is that, for example, on the modeling system for the global analysis, for example, and for all the regional monitoring and forecasting system, we will increase the days of forecast to 10 days, okay, for all the regional model. Also evolution on CIs. About the ocean color, we will have new ocean color products in the November release. We have a short, a mini release planned in July about the ocean color product. It's a sort of reorganization of all the products and the data set to give a better visibility and to simplify the comprehension of the different products, to have a clear view, clear offer of the ocean color product to our users. So This is planned in July. This is a short release, and this is a major release planned in November. So you can see the main evolution of the different products. Thank you. So this is the end of my presentation. I would like to dive perhaps too much deeper, but I think it's interesting to show you what is inside each services and how we try to build the next generation. And this is not a day-to-day work. We have to plan the major evolution on the long-term activity with the producers, with the users. So I hope you will learn something interesting for you.
Thank you very much, Fabrice, for this presentation, really showing again the dynamism and the very strong the user orientation of Copernicus in general and WEkEO in particular. Constant evolution, and the coastal products are a very good example. This is really something that is very important, because obviously coastal zones are very threatened by many phenomena that we are witnessing today: sea level rise, increased storms, etc., etc. So we see that these new data sets are going to be coming in the future, and I already know for sure that many users are eagerly expecting these products to be released. I see right now only one open question from Abdul Hasib Azizi. Is it possible to estimate FSC? I'm not sure I know what FSC is of my area of interest using Snap tool, or can I do it through WEkEO platform? Would it be chargeable or free of charge? Is there anyone of my colleagues wanting to take that question? So I believe, but I think if my colleague Amin is online, he can contradict me or confirm. But I believe if you want to compute it, and that's something you would have to compute from imagery, you have to use one of the plans that includes processing, and therefore outside of the trial period of 5 months for the basic one, you would have to pay. But you can still do it obviously by traditional way, by downloading it using Snap. I see no other question, so I can close this one and possibly move to my final remarks. We've organized a total of 20 webinars, which have gathered more than 1,700 attendees. That's also a high number, and that is not counting the many views of these webinars on the YouTube channel. And we have, yes?
Maybe you can share your screen.
I'm not sharing my screen? Oh,
No.
well, I'm sorry. It's a very good idea. That could be useful, could indeed be very useful. Although, let's go, here we are. So, yes. We've also worked hard to populate structure. Thank you again to all of you for joining today. For those who participated to previous webinars, thank you to also, and once again, an honor and a privilege to have served WEkEO, and we'll certainly see you around in other occasions. Thanks again. Oh, I can see a Q&M. Oh, no, just a thanks. Okay. There's a question. Is there a chance to see many of you still in WEkEO? Well, let's say it the following way. I can go back to that slide. The team that is on the right of that screen, that team is the WEkEO team permanent team. The faces you see on the left side, those faces are those of the user support team that just finished its contract. In fact, I mentioned it was led by CS Group. It was also supported by my company, Space Tech Partners. But it's all the ladies and gentlemen on the right are obviously staying with their organization, EUMETSAT, ECMWF, Marketo, Ocean, or the European Environment Agency, and they'll certainly participate in future activities of the WEkEO user support. I see no more questions, so I think, Joanna, we can close this webinar.
Thank you.
Thank you. Thank you very
Thank you
much,
very much.
Stefan.
Thank you very much.
Thank
Bye.
you.
Thank
Bye.
you,
Bye-bye.
everyone.
Bye.
Bye.